Hey everyone, today we're going to be looking at notes 1-3 combinations of functions. But before we begin, I want to remind you that your name should be in the upper right hand corner in pen. And then after that, I want you to go ahead and bubble these three given functions, f of x, g of x, and h of x. We'll be using these three functions all the way throughout this whole front page of these notes. All right, and let's recap some vocabulary real quick. So f of x is a trinomial. That means there are three terms here, 1, 2, 3. While g of x and h of x are both binomials. They both have two terms, 1, 2, 1, 2. Another thing g of x and h of x have in common is they're both linear functions. They both have x to the first power. While f of x is actually a quadratic function because it has this term here that has x to the second power. So let's get started with number 1. So number 1 says f plus g of x. That is a really fancy way of saying find f of x plus g of x. Okay, so we're going to drag down the problem. The problem is f plus g of x, and that equals f of x plus g of x. Well, what is f of x? F of x is this trinomial, so 3x squared minus 5x plus 4. And of course, I have used parentheses when I plug something in. Plus, and then I'll use parentheses again because now I'm plugging in g of x, this 2x minus 3. That's g of x. So now I've got f of x plus g of x. Okay? And in front of both of those parentheses is an implied positive 1. And when I distribute this implied positive 1 to all three terms and distribute this positive 1 to both terms here, recall that none of the terms will change. 1 times anything is itself, so everything stays the same. Okay? And then for our last step, we're just going to combine like terms as well as put the term that has the variable with the highest exponent in front. So that's our x squared term. So the x squared term will go in front, and then I'll combine my negative 5x and positive 2x to give me negative 3x. And then I'll combine my constant terms, the positive 4 and the negative 3, to give me positive 1. And then that'll be my final answer, so I'll box that up. All right, next example we have here, f minus g of x. That's a fancy way of saying compute f of x minus g of x. Okay, so what is f of x? F of x is 3x squared minus 5x plus 4. And then minus g of x, 2x minus 3. Again, notice everywhere I plugged in I used parentheses. Here you'll notice that I have this implied positive 1, and again when distributed it doesn't change any values or signs. Okay, however, right here this implied negative 1 will change the sign on both terms in this parentheses. So this will become negative 2x and this will become positive 3. When you multiply by that negative 1, both signs change. And then again, I'll combine like terms and keep that term that has the variable with the highest exponent in front. So then these will combine to negative 7x. And then my constant term, my term without the variable, will be positive 7. And notice I didn't write this down the whole way. I don't want to cause y'all to get hand cramps, okay? So it's totally fine with me if you do something like this. Okay, because it would be very tedious otherwise, as I bet you can imagine. All right, let's move on to number 3. So on number 3 here we have 2 times g minus f of x. Remember when a number's in front like that, that means times. So that's exactly what we're going to write. 2 times g of x, that's what that means, times, minus f of x. Okay, so let's plug everything in that we know here. So 2 times g of x, so let's find g of x. G of x is 2x minus 3. And then minus, and then f of x, which is this 3x squared minus 5x plus 4. Okay, now that I've plugged everything in, I can go ahead and distribute where necessary. Okay, so this is going to be 4x minus 6 minus 3x squared plus 5x minus 4. Of course, that negative 1 distributes to all three terms. And then remember, the term with the variable that has the highest exponent goes in front, so that's the negative 3x squared goes in front, and then combine those two to give you 9x. Combine this and this, the -6 and -4 to give you -10, and you've got your constant term. And for the final answer, y'all, I do require that you drag this down. You don't have to drag it down the whole way through, but for the final answer, I do need to see it. Okay, number 4. So number 4 has G, and that dot means times, as I'm sure you know. So G times H of X. So simply G of X times H of X. Now how we write it here will be a little different. I'll explain. So G of X, remember when you plug in, you have the parentheses, is 2x minus 3. And then H of X, since I already need parentheses to plug in, there's really no reason to put a dot in between because these parentheses backed up next to each other implies multiply. So we know we're multiplying here. And a binomial times a binomial means I'm going to double distribute. So distribute the 2x to both terms. So that's going to be 6x squared plus 2x. And then I'm going to distribute this second term to both of these terms. So -9x minus 3. So that would give us 6x squared minus 7x minus 3, yes? So final answer, G times H of X equals that trinomial there. Okay, moving right along to number 5. So number 5 has F and G right next to each other, and hopefully you know that that also implies multiplication. So that's another way of saying F of X times G of X. All right, so F of X, let's come up here and make sure you can see it. F of X is this 3x squared minus 5x plus 4, and then G of X is the 2x minus 3. So I'm just plugging in. Now I'm going to have to move up so you can see. And here I'm going to have to do some triple distribution. So distribute the first term to both of these terms. So that's going to be 6x cubed, agreed? And then negative 9x squared. And then I'm going to distribute the negative 5x to both terms. So that's going to be negative 10x squared plus 15x. And then lastly, I will do, that'll be 8x minus 12 when I distribute that last term. So I distributed this term to both of these, this term to both of these, and this term to both of these. Okay, and that's why I don't like FOIL, because FOIL doesn't work when you have a trinomial times a binomial. You just really have to think of it as distribution. Okay, so the 6x cubed first, then negative 19x squared second, then 23x next, and then my constant term, my term without the variable last. All right, we're chugging right along, aren't we? Notice my exponents descend. 3, 2, 1, and then there's none. Cool. Okay, number 6, G minus F of 3. So hopefully you're already kind of looking at this saying, this is different from before. This is different from before because unlike all the other problems, I have a number here instead of an X. Okay, so what's going to change? Not much, all right? Not a whole lot. We're still going to set it up the same way, okay? G of 3 minus F of 3. And now here's one thing that's going to change. When I have a value in there and not an X, because I know I'm going to be double plugging, you'll see in a minute what I mean by that. We'll be double plugging. I use brackets because they seem to confuse students less than double parentheses. So here's what I mean. I've got a bracket for G. So G is this guy right here, 2x minus 3. But again, my input is 3. So instead of writing 2x minus 3, I'm going to write 2 times 3 minus 3 because my input is 3. I'm plugging in 3 into x. Into the function of f. So there's the function g, but in g I plugged in 3 where I saw x. Now let's do f, but where I see x, I'm plugging in 3 because that's what it tells me to do here, plus 4. Okay, and so like I said, I use brackets around the g function and the f function. That way it's not double parentheses because in years past when I used double parentheses, students got confused. Okay, so here let's just evaluate this. So this is going to be 2 times 3 minus 3, so that's 6 minus 3, which is 3. minus, and here I must follow order of operations, and since I have this exponent here in this term, I need to take care of that first. So 3 squared is 9, so I'll have 3 times 9, and then here I can go ahead and multiply that to be negative 15 and drag down the plus 4. So then I've got 3 minus 3 times 9 is 27, so 27 minus 15 plus 4. So let's talk about that. And really the bracket here isn't even necessary anymore. 3 minus, this is going to become 12 plus 4 is 16. So 3 minus 16, which is negative 13. And y'all, I hope that this is making sense, that our final answer here for this problem is a value. Okay, that's because our input was a value. Our input was a value, so our output was a value. Here, when our input was an x, we had x's in our output. Do you see that? So here, when our input was a value, our output was a value. Okay, let's keep moving right along. Last problem on this page. Okay, so this g plus h of 1/3 means g of 1/3 plus h of 1/3. And again, since we've got a value here instead of a variable, I'm going to use brackets. And you won't be able to see it on my page. I don't have enough space to go up and you to see both, so you're going to have to look on your page. G is the function 2x minus 3, except where I see x, I plug in 1/3. H is the function 3x plus 1. Again, I'm saying x, but where I see x, I'm plugging in 1/3 because that's what the problem's telling me to do. So then I just compute. 2 times 1/3 is 2/3, yes? 2 times 1/3 is 2/3, minus, I'm going to change that to 9/3, so I have a common denominator. Wouldn't you agree? 3 is the same as 9/3. And then here, 3 times 1/3 is 1, so I've got 1 plus 1. And then here I can really take away the brackets now because I have a value. So the value here is negative 7/3 plus 2 is my value here. Okay, and then I'm going to do negative 7/3 plus 6/3. Would you agree with me that that's 2? Okay, so getting that common denominator. And then last, negative 1/3 is my final answer. So of course, for my final answer, I will drag down the problem. Okay, and it makes sense that our final answer is a value. Since our input was a value, that means our output was a value. Okay, and if that fraction stuff was giving you issues, you probably need to go back and watch the fraction video, get some fraction practice problems from me, or see me in tutorials. Okay, let's move on to the back, which will go surprisingly fast. So using the tables below, find the values for the given combinations. Before we do this, I want to remind you, I've been saying it, but I want you to see it. Remember that x is the input while y is the output. So here, just like the front, this f plus g of 2 means f of 2 plus g of 2. Okay, and even though this is a value here and not an x, we're not going to have to use brackets. I'll show you why, unless you want to, but I don't think you'll need to because you're going to see how fast this is going to go. So remember, that 2 is replacing the x. That's our input. That's our x or our input. We want the output. So f is this table here. Of 2 is our input. What's the output? Oh, it's 5. Drag down the plus, and then we want g of 2. So g is the table we're looking at. Come over here. Our input is 2. We want the output, which is 7. So 5 plus 7, which is 12. Yes, I'm serious. That's it. We're done. Can you believe it? Told you it's going to go fast. Okay, so that's number 8. Number 9. So this g minus f of 3 means g of 3 minus f of 3. Okay, so be cautious. It's giving us g first, so I need to come to g. G of 3. So my input is 3, my x is 3, my output, y, is 8. Minus f of 3. So come over to f. My input is 3, therefore my output is 6, what I want. All right, 8 minus 6, which is 2. G minus f of 3 equals 2. All right, for the graphs. Using the graph at the right, find the values for the given combinations. Okay, notice that I have it underlined here. This dashed graph is g of x, while this solid graph is f of x. Okay, be very cautious of that. So here f plus g of negative 6 simply means f of negative 6 plus g of negative 6. So we need to find the function value at negative 6. In other words, our input is negative 6, we want the output. Our x value is negative 6, we want the y value, on the f graph specifically. So I'm talking about the solid graph. So I'm going to go find my x value. Remember, that's the input or the x value. I'm going to find x is negative 6, which is right here, and I'm specifically looking for the f graph. That's the solid graph. So that's this point here. This point here has an input of negative 6. What's the output? What's the y value? Oh, it's 3. Okay, and then plus. Now we're looking at the g graph. Now we're looking at the dashed graph. Okay, so my input is negative 6 still. All right, so x value is negative 6, and I want the dashed graph, so that's this one. What's my output? So that ordered pair is negative 6, positive 4, so my output is 4. The y value is 4 there. Okay, 3 plus 4 is 7. You're done. So you're being given the x values, and you're trying to find the y values. You're given the input, and you're trying to find the output. You're given the x, you want the y. You're given the input, you want the output. So similar here, g of 8 minus f of 8. So be cautious, we've got g first. So we want the g graph, we want the dashed graph, and we want the input to be 8. So we're going to come on the x-axis at 8, and we want the dashed graph. We want the g graph. So g of 8 is 4 minus, what's f of 8? So 8 on the x-axis, here's our solid graph. The y value here is 0. 4 minus 0 is 4. We're done.